There it is. No, wait, that doesn't work very good either. That's, it has to be the same thing every time, but then it gets boring and people won't want to be subscribing anymore. Okay. I need a signature phrase. So maybe we should have a poll to see what my signature phrase should be. Yeah. Okay. All right. So, believe it or not, the T distribution is robust. That's a strange way to describe a distribution, but robust, in the true meaning of the word, kind of means like strong and sturdy, maybe kind of a little bit fat, kind of. Okay, so it's got that extra area in the tail, so the T distribution's kind of got a big butt, so it's robust. All right, so robust means, in this case, robust means that we may not have to meet every condition. And the condition we won't need to be a real stickler about is normality. So we don't need to be picky about normality. We still need to address it. We always have to talk about it, but we're going to end up doing the procedures using the T distribution, even if things don't quite check out with our sampling, our population being normally distributed. Yes, because it's robust, we don't have to be picky about things. That's what robust means in statistics. Okay. We can almost always use the T distribution when we want to. Okay, this is when we can't. We use the T distribution when we're doing means. So, all right, unless we don't have an SRS or something that is as good as an SRS, or if we have a very small sample, let's say in less than 15, and we have outliers in the sample. If our sample size is less than 15 and we have outliers in the sample, no go. Can't use the T distribution. Or if n is a little bit bigger, let's say if n is between 15 and 30, we can go ahead and use it as long as we don't have big outliers. Yes. So we can't use it if we have great big outliers. But we can use it if we just got one outlier or two outliers and they're not really far from the rest of the data. Okay? So and if n is greater than or equal to 30, doesn't matter how many outliers, no matter how skewed our box plot says that our sample is, we can use the T distribution. So those checks will work for us. And basically, to check about outliers, we'll just make ourselves a little box plot and show there's no outliers. Yes, sir. Okay. So that's the easiest check, and it's the quickest one to do in your calculator. Yeah. Okay. You can use it unless you don't have an SRS, or if you got outliers, if you got big outliers. If you have a small sample with some big outliers, you probably shouldn't use the t-distribution. If you've got a medium-sized sample and you got outliers and they're not really extreme, then go ahead and use the t. If your sample size is bigger than 30, you can use the t-distribution even if your sample does have outliers and big ones. Doesn't matter. Yes, sir. Yeah, well, it's a matter of your opinion. There aren't any real standards. It's a matter of how conservative you are. So you get to decide. Okay. And it's a bit of taking your chances anyway. So hopefully you have done correctly, decided correctly. Okay. So let's do an experiment that's kind of outlined in your book, and see how this whole robustness works. Here we go. The caffeine study. They always call them a study, but it's not an observational study. It's an experiment. Sometimes studies are observational studies. Sometimes studies are experiments. We have 11 subjects who are dependent on caffeine, heretofore known as caffeine addicts. And they're going to give we're going to give them some tests to measure their reactions about certain things. And we're going to give them the tests sometimes when they have caffeine and sometimes when they don't. Okay? So the subject will come in on a specific day. You'll tell them what day to come in. And they'll be given their you'll tell them don't have any coffee or Cokes this morning. And then when they get in, you give them their normal caffeine dose, whatever they would normally get in the morning. But you give it to them in a capsule. And then you're given this battery of tests. Okay? And then on a different day, the subject comes into the office and they're told don't have your coffee this morning. And then they're given the tablet, and it's not a caffeine tablet, it's a placebo. And then they're given the same test. They shouldn't quite recognize that they're being given the same test, but or maybe it won't matter depending upon what the kind of tests are. Okay? These different tests, these different treatments, the order in which they're given is randomized. That means maybe the first time you come into the come down to the office, you get the placebo, and the second time you come, you get the caffeine, or the first time you come, you get the caffeine, and the second time you come, you get the placebo. That's randomization of the treatments. That's an important thing to do. Okay? What do we call this kind of study? It's this kind of experimental design. Matched pairs. Who is each subject paired with or matched with? Themselves. And is this experiment blind? Yes, because they don't know if they're getting a caffeine pill or a placebo. Is this experiment double blind? No, I've said nothing about the double blinding. Does it need to be double blind? Probably not. It depends if you're just doing multiple choice tests. Who cares whether the person that's in the room with you knows what treatment you got? If you're being given a very subjective test, then it needs to be double blind. So we're going to say maybe these are objective tests, and so it won't matter. Okay. Now here's one test that they took, and this is a depression test. So it's a multiple choice test. And if you score, the higher your score, the more depressed you are. And for each subject, we have their score on this depression test when they were given the caffeine pill, and their score on the depression test when they were given the placebo. Okay, so throw these numbers into your calculator to start off with. I would go list 1 and list 2. Did you change my lists at lunch? Oh, okay. So mine are still in there. Mine are still in there. Okay, good.